Hey everybody, this is Mr. Brooks. This is part 2 of polynomials, and today we're going to talk about multiplying two binomials. So first we started with adding and subtracting, and with polynomials, since they're a number, you can always do every operation with them. You can add them, subtract them, multiply them, and divide them. Okay, so our learning target today is I can multiply two binomials. I can multiply two binomials together using the FOIL method. And I'm going to start off with this slide, and I want you to look at it, and I want you to tell me what you notice. And so these are two factors. This is x minus 3 is one factor, x minus 2 is another factor. And factors are, of course, two numbers that you multiply together. So, for example, 6 times 2 is 12. 6 and 2 are factors. So this is one number, x minus 3, another number is x minus 2. Multiply them together, you get this result. Same thing with these two factors multiplied together, you get this result. And same thing with these two factors multiplied together, you get this result. So think about it a little bit, pause the screen if you need more time, and think about if you see the pattern. Okay, so what we start off with is two binomials, and we get a trinomial. Two binomials, trinomial, two binomials, trinomial. And this is normal. There are some weird cases where you don't get a trinomial, but you should expect to get a trinomial, okay? And then maybe the other thing to look at is x and x. There's two x's here, so when you see two x's multiplied together, you add the exponents, you get x squared. X times x is x squared, x times x is x squared. And then if you look at the back number, you have negative 3 times negative 2 is positive 6. Negative 1 times positive 5 is negative 5. Positive 2 times positive 4 is positive 8. So we've covered the first number of the trinomial. We've covered the third number of the trinomial, or part of the trinomial. And we're going to find out how to get the middle, okay? So the method that I use is called FOIL. It stands for first, outside, inside, last. Notice there are 4 parts, and it basically means we're going to multiply 4 times, okay? So 4 simple multiplication steps, and then we are going to combine like terms. And what you have is a problem that takes a little bit more time, a little bit more thinking when you first start out, because maybe in middle school multiplying two numbers together was a problem. Now multiplying 4 numbers together is one problem. So it's a little bit bigger, a little bit more complicated, a little bit more brain power, and that's what we're going for, okay? Notice first terms 2x and 5x are the first terms, and 2x and negative 8 are the outside terms, they're on the outside. 3 and 5x are the inside terms, they're on the inside. And 3 times negative 8, those are the last terms in the two binomials. Okay, so let's start off. And what I'm going to do first as a strategy is I'm going to realize this is FOIL, so I'm going to draw an arrow here, draw an arrow here. That's distribution property, arrow, arrow. And that reminds me what I'm doing, so I don't get two multiplications in and then forget what to do next. Another word people use to describe this is double distribution, because you're distributing the k and you're distributing the negative 2. Okay, so k times k, so k times k is k squared. So k squared, and then k times negative 3 is negative 3k, and look how easy it is, you just stick them together. Negative 2 times k is negative 2k, and then negative 2 times negative 3 is positive 6. So that's our 4 multiplications. It's first, outside, inside, last. And now the last step is, because remember we're trying to get a trinomial, it happens that when we multiply these, the middle terms, when you use FOIL in order, are like terms, negative 3k, negative 2k. You can simplify that. So you should get k squared minus 5k plus 6. And that is your answer. So k minus 2 times k minus 3 is equal to k squared minus 5k plus 6. Okay? Let's go another one. Okay, here's this. I'm going to make this a little bit bigger for us. Okay, and if you remember the strategy, highly encourage you when you see this to draw the arrows. But this is when you multiply. So later on in polynomials, we're going to do some other things with them. And so you really need to read the instructions carefully to know what we're doing. If it says multiply, or if it says find the product, or if it says simplify this, then you're going to do the FOIL method. So 3x times x is 3x squared. And that was the other pattern, right? It was x squared, x, and then the constant. 3x times 4 is 12x. Oh, my 2 got away from me a little bit. 3 times x is 3x. That is the inside. And 3 times 4 is 12. Oops, that remained my first mistake. 3 times x is 3x. So you can always go back and double check. Like it should be x squared, x, just a constant. So definitely, see the pattern so it helps you out if you miss something. Okay. Middle terms is x and x. That's good. And we have 3x squared. 12x plus 3x is 15x. And the last part is 12. And that is our product, the answer to multiplication. Okay. Okay, this is not a method that I prefer, but for some students, they like this because it's going to make it a little easier for them. So I want to show this to you, and if you struggle with FOIL, you're more than welcome to do this. I want to encourage you to find a way that you like. So this is the box method. I'm going to multiply these two binomials together, and what I'm going to do is I'm going to write the first binomial across the top, multiply the second binomial across the side, and it doesn't matter the order because a times b is the same as b times a. It's commutative property again. And what I want to do is I want to multiply through the boxes. So this is 3b minus 3. Notice I'm taking the negative signs with me. So if you have a negative sign, you need to attach it. So here in 3b and b meet in the grid right here. So 3b times b is 3b squared. 3b times negative 1 is negative 3b. b times negative 3 is negative 3b. And negative 1, negative 3 is positive 3, right? Okay, so we got our four products. We multiplied together. Now what about the combining like terms? Well, it's always these. And these are what we're going to combine, right? So we have 3b squared. Combine negative 3b and negative 3b is negative 6b and 3. And there's our trinomial. So same result, okay? Okay, one more thing to point out. Okay, in this case, we have a binomial squared. So x plus 5 is our binomial, and we're going to square it. Okay, Jill says it's x squared plus 25. So it looks like she squared x and she squared 5. And Bill says, no, that's not right. It's x squared plus 10x plus 25, which you see the x squared, you can see the 25, but he added a 10x. So who is right? Think about the rules you've learned, and think about if you've ever heard of distributing an exponent across multiplication. Or I guess the best way to do it is to think about what squared means. Squared means you take a number, and x plus 5 is a number. It's just a number, and you multiply it by itself. So therefore, the rule is you need to multiply it by itself. It does not mean distribute the exponent. Okay, so this is the example of a worksheet I found. So it's not the same x minus x plus 5 squared, but the words I use is write it twice. You have to write it twice. If you write it twice, then you can't mess up. And there's a pattern to this. Later on you might learn the pattern, and you can just do it in your head as an algorithm. But if you write it twice and then you follow the FOIL method, then it should be kind of same as you've done before. So 3x, 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 4, 4, 3x, 4, 4. 3 times 3 is 9x squared, and 3x plus 4 is 12x, and 4 times 3 is 12x. And you can kind of see the pattern now if you're good. And 4 times 4 is 16. Here's our like terms right here. And so you have 9x squared plus 24x plus 16. And we do indeed follow the pattern of getting a trinomial when we multiply two binomials. Okay, so when you have a binomial squared, you are multiplying two binomials together. Okay, you're multiplying the same binomial by itself. Okay, that's multiplying binomials. Good luck with the homework, and we'll see you in the